Welcome back to Backspace Academy. In this video, I'm going to run through the core knowledge that you will need for Amazon S3 for the associate level certification. And this will be core knowledge only, and we'll get to give that to you in the shortest amount of time possible. And then from there, you will branch off into the developer or solutions architect or SysOps administrator to get further knowledge in that specific area. So Amazon S3, it is one of those abstracted services. So what that means is that we don't particularly fully understand how it works. We understand that there's obviously going to be a server there somewhere and load balancers and disk drives and the like, but we don't particularly understand how that works, and it's one of those abstracted services. As such, it does have its own unique terminology. So we don't talk around about partitions and files and the like. We talk more in the perspective of buckets and objects and keys. So a bucket, that is a uniquely named container for objects stored within S3. So you can have multiple buckets in an account, so up to 100 buckets per account, but that can be increased if you put in a request to Amazon Web Services to have that increase. So it's not a fixed amount. You can actually increase it if you request it of Amazon Web Services. So what that means is that if you're, for example, a web developer, you would probably have a bucket for each one of your customers, and you would put all of their information in one of those buckets. Now, the total volume of data that can be contained, or the number of objects that can be contained within a bucket, is actually unlimited. So it's a very good service, a very scalable and highly available service that is very abstracted, so you don't really need to worry too much about a great service. Within a bucket, objects. So that could be an MP3 file, it could be a video file, it could be a document. But they are actually entities which consist of the data and also metadata that is attached to that data, and they're stored within a bucket. And so those objects, the data can range in size from nothing, from 0 bytes, up to a maximum of 5 terabytes. Now, there are some restrictions around that if you want to upload 5 terabytes. So you can't upload a 5 terabyte object in one hit. So the largest object you can upload is 5 gigabyte. So to upload 5 terabytes, you will need to use multi-part upload. Now, that is recommended by AWS for all objects that are over 100 megabyte to 5 terabyte. And that will provide the most streamlined method of getting large objects into Amazon S3. Also, we have keys. Now, keys are a unique identifier of an object in a bucket. So an object will be uniquely identified by its bucket and its key and its version ID. So if we have multiple versions of a document, for example, each one of those versions will have a version ID attached to it in its metadata or in its keys. Now, buckets are unique, so the name of a bucket needs to be unique. So if you want to call your bucket Google or Microsoft, you're not going to be able to, apart from the obvious copyright reasons and whatever. The name will well and truly be taken. So those bucket names need to be unique across the entire Amazon Web Service. So sometimes you need to be a bit elaborate with your bucket names to get that unique. Now, one thing to consider here is that S3, it's not a file server, okay? It's a web store and not a file system. So that the main difference there is that it is eventually consistent. What that means is that the read after write consistency varies depending on what you're doing. So if you write to Amazon S3 and then you read immediately afterwards, that's not necessarily consistent. It is eventually consistent. And so what that means is that when we upload something to Amazon S3, or we change the data within Amazon S3, that will be synchronized across multiple availability zones. So that's going to take a very short amount of time, but it will take a a period of time. And so after that has occurred, the index that Amazon S3 uses to keep track of all its data will be updated. So what that means is that although the file or whatever might have been changed or updated, the index may not have been updated. So that is something to consider. So with new objects, so they have read after write consistency with new objects that are synchronized across a multi availability zone before they're indexed. So what that means is you would use, or an API call would be made to upload a new object. And when we say an API call, that could be through the console, and the console is in reality a web application that uses API calls to get things done. So an API call will be made to upload a new object to Amazon S3. That object will be uploaded. It will then be synchronized across multiple availability zones. After that has occurred, then the S3 index will be updated. And then once the S3 index is updated, then a success callback will be returned from that API call. So that's what we mean about read after write consistency. So it won't give that success call until the S3 index has been updated. Now, the other difference is when you are updating or deleting an existing object. So they're not read after write or read after delete consistent. So what will happen is that you will have a API call to update or delete an existing object. So after that object has been uploaded, the success callback will be sent back from that API call. And then after that, it will be synchronized across multiple availability zones, and then the S3 index will be updated. So what that means is that if you fire off a delete, and then immediately after doing the delete, after getting your success callback, and then you do a read, it is possible that you will still see that deleted object still there on the index. So that's something that you need to take into consideration, especially if you're a developer, to make sure that your code works as you expect it to work. So AWS S3 again is one of those abstracted services, and as such, it takes control of a lot of the AWS IAM for us, and it is actually secure by default. But of course, although it does take control of a lot of that for us and manage a lot of that for us, we can modify that if we like. So we can do that through IAM roles, users and groups, and that will be fine-grained control. So in our JSON file or whatever we're using for IAM, we can get that quite specific as to what we want and the details that we want around that. So it's fine-grained control. The other way we can modify it is through bucket policies. Now they're also fine-grained control, and they're applied only at the bucket level. So you only apply that on an actual bucket. You don't apply that on the objects inside the bucket. So a bucket policy applies to the entire bucket. The next thing that you can do, which is an access control list, you can use that for modifying the security. Now that's applied at either or the bucket and the object level. And that is not fine-grained control, that is coarse control. So it does not have the level of control that you would have, or the level of detail that you could get out of an IAM role or a bucket policy. Now, the way that you upload objects and the naming of those objects can affect the performance of your S3 bucket. So what you use for a key prefix will affect that performance. So what we mean by that, if you're uploading objects and they're all called object 1, object 2, whatever, or you're creating folders that are called folder 0, 1, 2 and whatever, like we've got there, that will be quite a slow process because your partitions are based upon key prefix. So you're going to be creating that within one partition, and your searching of that through Amazon S3 will be significantly slower than if it had making advantage of multiple partitions. So the way that you can do that is by making sure that your key prefix is not the same. So the easiest way to do that is to just put the numbers at the start. So if you're using a folder there, you would have the numbers at the start. Where we've got here 0 folder 1 folder instead of folder 0 folder 1. You can, if it's a number, you can just reverse the entire object name, and that will get the same effect. You can use random names and hash values, but normally something like this is suffices. So you need to understand that the key prefix does affect S3 performance. Now, the S3 storage class. So S3 is not just one specific storage class. There are a number of those, and they can also lead into archiving to the Glacier service as well. So the three main, or the three S3 services there are the most common one is standard. So that is 11 nines of durability. So that's 99.99999. Okay, so that's 11 nines of durability. So it is very, very durable. It's very fault tolerant, and there's a lot of redundancy built into that service. Availability. So it is 99.9% available. So it is using your data, or it is copying your data across multiple availability zones, so it's going to be available, quite highly available. It also supports SSL encryption of data at transit and rest, and that is something, being an abstracted service, that it does take a lot of the work out of that for you. And it also has lifecycle management. So as objects get old, they can be deleted or they can be transitioned over to archiving in the Glacier service. The next one we've got there is a newer service, a newer type of S3 that was introduced in late 2015, I think, and that is a standard infrequent access. And so that has all of the same main features of S3 standard, but it has a lower per gigabyte storage price. But it has a per gigabyte retrieval fee. So if you're not using it that often, it will cost you less. But if you are using it often, if you are retrieving that data often, then it will be more expensive than standard. So if you have data that's not that commonly accessed, then that's a good service. So it's kind of fits in between standard and Glacier. So Glacier takes a long time to get your data, whereas standard can get it quite quick. But you will be expensive if you're accessing that regularly. So the next one to look at is reduced redundancy. So what that means is, instead of 99 or 11 nines of durability, it's got 99.99% durability. So it doesn't have the same amount of redundancy that standard or standard infrequent access has. So you would use it for non-critical data. The data can be reproduced easily. So it's not, if you're using, say, a good example would be if you have a master video file and you've got multiple versions of that video file that, for different resolutions or whatever, that can be reproduced quite easily. You might want to have your master video set up in standard, and then using reduced redundancy for your other copies of that reduced resolution. Put that into a reduced redundancy bucket, or as a reduced redundancy object. It still has the same level of availability that standard has, so it's still 99.9% available. Now, if you're using a lifecycle management, you can archive through to Glacier as well, or you can actually go directly to Glacier. But so that is low-cost storage, the lowest cost storage that you can get as opposed to S3. But the downside is that the retrieval time will be several hours to get that back again. It has some good features there. So it's got a vault lock feature, which enforces compliance across a lockable policy. So that is a very good service for backup of critical data. So what is lifecycle management? So that enables you to have objects deleted after a certain amount of time. So if something's old, we can just delete it after it expires if it's not critical information. Or if we want to archive that information, so we don't really need to have that accessed anymore, we can delete it and archive it. Or we can back it up, so we can actually archive and go to Glacier. And so we can also restore that back from Glacier back to S3. So that's what we mean by lifecycle management, and we'll talk more about that, and we'll have some hands-on work in that area in later videos. S3 versioning. So we have a very good service within S3, so we can apply versioning to a bucket, and so objects within that bucket can will have versions. So if we delete that object, we can actually get it back again by looking at the versions, or if we change that object, we can go back to previous versions of that object. And so individual objects can be restored to previous versions, and also deleted objects can be recovered. So that does help increase security and reliability of your data if you're using versioning. So another new feature of S3 that came out, I believe, again, around late 2015, I think, or early 2015, is cross-region replication. So that is quite good because whereas before you had to select one specific region for your S3 bucket, you can now have it located across multiple regions. So it's a very good thing for reducing latency for end users. And so if you've got your infrastructure set up in multiple regions, you can also have your S3 buckets set up in multiple regions as well. So if you're using versioning, so you'll need to have the source and destination buckets will need to have versioning enabled if you're using versioning. The ACL, access control list details, will be updated as it's synchronized across. And the S3 enabled encryption, so the encryption that is built into, that is managed by the S3 service, will be managed also in the other region. But if it's encryption that you're managing yourself through KMS encryption, that will not be replicated, so you would need to look after that yourself. And if you've got existing objects when you're first starting this, you'll need to copy those existing objects to the new region. So S3 cross-region replication, a reasonably new feature to Amazon S3, and very, very good feature, so you need to be aware of that. You'll find that that it will come up on being a new service. Anything that's a new change to an Amazon S3 server or any Amazon service, you will pretty well guarantee that it'll be on the exam. So that brings us to the end of the core knowledge that you require for Amazon S3, and hopefully we've got to that very quickly and got to as painless as possible. And I look forward to you in the next videos.